Well, hello. So we have an iPhone 11 Pro that apparently has no Wi-Fi, grayed out, no Bluetooth. Let's see, what about no modern firmware? We can see a crack here, so I don't know if it was after this bump or it just stopped working. But let's open it. I wanna see one more thing. Flashlight gone, so flashlight not working either. What about the voice recorder? Let's see. So no voice recorder, meaning that we definitely have a problem with the board, the RF board. Okay, let's have a look under the microscope, because this board has already been desoldered and resoldered back by somebody. Oh, there's definitely no contact here. So I told the guy to remove the board and clean it and do a few measurements, and if nothing is wrong, put it back. You can see that this part here is not soldered at all. Of course you cannot see microscope. So the pins here are not making any kind of connection. Probably also in this area here. So it might be just a bad connection issue. Let's remove the boards, desolder them. If we can find the 11 plate. Good. 190. 4 minutes. We don't stay that long.
I can hear the demons call when they do what they do, and now I feel like taking off, find a place with a view. The pain is never gonna stop if it's controlling you. I know that time can heal it all, I just gotta get through. I just gotta get through, I just gotta get through. Cause I feel like taking off, find a place with a view. The pain is never gonna stop if it's controlling you. I know that time can heal it all, I just gotta get through. Sometimes I feel
Just do a visual inspection. I'm just looking at the interposer now, and then we'll also have a look at the board. Alright, so interposer is good. There's only one thing I want to measure here, and that's the 3VFE line here. If this one is shorted, then we could have the symptoms that we have now. We'll put the meter in diode mode. Okay, put the red probe on ground, which is one of these PAs, and the VFE is 0.5, so that's good. Okay, let's go to the bottom. Let's measure on the bottom also the 3VFE line, 3V15. Okay, this is not shorted either. So it might be that it's only an interposer issue. I'm noticing here near the NFC, it's like a burn mark here, like coming from this cap. This is the baseband PMU. Nothing out of the ordinary there. These are the diodes that I spoke about, so you need to be careful not to break them. There's actually one broken here. See? So we're gonna have to replace that one, this one here. Right, so cool. Let's continue. Can't spot anything else, so it's just this cap here. Let's measure it. It looks like there's a hit signature. 0.3, that's not bad. Let's measure around. Let's see if there is any short. So there's no apparent shorts. Oh, sorry. No shorts. Okay, so no shorts. This diode here, I don't like that it's broken. Let's give it some flux, and 1 second, I'm gonna pause the video because I'm gonna look for a donor board. 1 sec. Okay, so found a miserable one. I can deal with that. Let's see if it has the diode. Yeah, so diode is there. Okay, let me add some flux. And first, let's remove this one. Let me put the board somehow like that so I can safely remove and replace now. I'm gonna do 380. This is gonna take some heat because it's near the interposer. Board is cold. Okay, don't fancy the fact that it's near the baseband EEPROM, right? Let's put some solder there. Let's see, is this too big? Or we can fit this tip in there. Okay, I think it's good. There's a piece of dirt there, and I have too much solder because that's a ground. Alright, so let's remove the good one. Okay, so it's in place. Can't clean it with that. Alright, so let's now check the interposer. Let's see how it looks on the bottom board. So it's not bad. While it's still warm, let me try to add some flux. Let's see if it's warm enough. There's not much solder on this, but I'll try to sort it this way. Let's put it back on the heater. Stop board is bent. Why is it that bent? Okay, so I'm gently bending it back. I don't really like how the solder looks under this PA. It looks good, it's just a reflection. Okay. Okay, and now let's try to align this the best we can. Okay, I don't think we can get it better than that. Let me switch to this camera. Alright. Okay, so I think we are ready now to put the weight. I'm gonna do a smaller weight here, smaller one here, and the big one I'm gonna put it here. Okay, gonna press gently on down. Okay, and now I'm stopping it and starting it again, but I'm not gonna start the heater. I just want to see the temperature. So when it's gonna be around 90 degrees, we're gonna take the board off and see the result. I'm gonna pause the video now. Cool, so we're at 100 now. I think we can remove the weights. And we can lift off the board, as it will cool faster here on this mat. I use the air pump. Okay, and let's clean it with a bit of alcohol while it's still a bit warm. Alright, and now let's have a look. You should be able to see it alright. Okay, so I'm still not happy with the way it comes here, but I'm gonna see, I can still see some space there. But I'm gonna do a trick because we have those spacers, and I'm gonna come with hot air and just heat this up. And I'm gonna use the tweezers to squish it down. Okay. And now I'm gonna blow some air on it to cool it off. Remember, this is low melt, so it melts at about 140 degrees maybe. Alright. This part here I'm also not very happy with. Let me see how I could grab it and squish it a bit. We're gonna do the same thing. Apply hot air here. Don't have a very good leverage. Alright. There are some components here that are underfilled heavily, so I don't want to insist with the hot air too much. Let's see how it looks now. I think it's a bit better. Okay, let's cool it off again. And let's clean it again with some alcohol. It also helps cooling it off. Right, so I think it's cool enough. Let's give it a try. If this isn't working, then I might consider a problem with the baseband power management IC. So we will replace this one also, if it's still failing now. See, they left all the screws here and the foam from that is around the connectors. That is nice. So let's see, does it start anymore? Yeah, we got an Apple logo. What about flashlight? So it came up a bit late. It might be maybe because I don't think this back is original though. It might be because it was still booting and the I2C line was still busy. But at least we have okay, we have a lot of Face ID errors. Okay, no IMEI. But we have we have Wi-Fi now. Interesting. So, general informations. We still have no modem firmware. And the software is 14.7, so I don't think it has been updated. Because if you update while you don't have and the Bluetooth is still not working, so we still have a problem. Oh, no, it's working, sorry. Bluetooth is working, but we have an error on the cellular connectivity. So it's definitely an interposer issue. Right, so what I did was I reballed the boards eventually. I put them back. Still we have Wi-Fi, but we do not have any IMEI, so the basement is dead. There's no modem firmware. Next sensitive step would be to do a swap, but I'm not a huge fan of a swap. So first thing, I'm gonna try to investigate if maybe there's a problem with the baseband PMU. Now the board doesn't seem to have any hit on either side, so it doesn't seem damaged. Yeah, before doing a swap, because swap means preparing a new board, then you need to remove the baseband CPU, we need to transfer the baseband EEPROM data, and I will also move the Wi-Fi chip, although on the 11 we can unlock the Wi-Fi and use a different chip, but for that we need to remove the NAND. So removing the NAND, which is on the opposite side of the CPU, is a bit worrying. So I'm not gonna remove the NAND, I'm just gonna transplant the Wi-Fi IC, the baseband CPU, and I'm gonna copy over the EEPROM baseband EEPROM data. But before doing a transplant, it's sane to check the baseband PMU first. In theory, you could take a power management chip for the baseband from a different board and replace this one. It's not, it's quite straightforward, because if we look under the microscope, there is no underfill here. So in theory, just remove it, get a new one, reball it, and put it back. Then you need to solder back the boards and then test it again. But we can do an actual trick. So we can power on only this bottom board. It's not very difficult. We need to power on the VDD main line and the reset low line. You see here 3 wires. I have the baseband reset line here, baseband PMU reset line low. I have the VDD main line and I have a ground, right? So now let me switch the camera, so you can get a better picture. Sorry, but it's a bit difficult here. Right, okay, so we have a bigger picture now. Let me do a bit of a close-up like that, because we're gonna need the multimeter. And I've connected this to the power supply, and I'm gonna power it on at 3.1 volts. Let me show you also the power supply. You can see it here. In theory it should take about 30 to 50 milliamps. So let's see, let's connect to the power supply. Alright, and I'm gonna power on the power supply, and you see it's set to 3.1 volts, so I'm not gonna put the reset low. It's a 1v8 line, I think, so I'm not gonna put 4 volts in it. I'm gonna put 3.1. that's enough to power on the system, and you see it's taking like 32 milliamps, so we're fine. And if we bring the schematic here, alright, I'm mostly interested in the power of the baseband. So we have here this 0V85 line, and let me take the, let's power on the multimeter, actually on volts, right? So you can see here the multimeter. I'm gonna take the probes, alright, and let's see if we can do it this way. Yeah, you can still see the multimeter. The board is powered on, and we can probe around this cap. So the first one I said is the VDD dig 0V85 we should have here. So we're almost correct there. Good. Let's see another line. For example, this one in the corner should be the DDR1V1 line. This one right here. And indeed we have 1V1. Let's see what other lines do we have. We have the VDD-IP 1 volt here on this cap right here. Yeah, so we have definitely 1 volt. That is good. This is the VDD-IO 1V8, and it should be this cap over here, and we have 1.8 volts there, right? So we are correct. This is the 0, yeah, we already been there. 1V8 again, it's this big cap here, is the same line. So we've already been there. 1.8. What else do we have here? We have here the SRAM. Let me put it like this. So we have the 0V9 SRAM, which is this big cap here, right? And we have 0.9 volts. Okay, and that's about all we have around the baseband. There is also some PPVDD SIM2 here, but I don't think it's out of much interest. This is for the SIM, and I don't think it's gonna be active now. Okay, what else do we have here? We have the main line, which we know we have. We have an NFC VDD boost, which is right about here. Yeah, we have 1.2. I don't know what else we have here. Nothing interesting. Around the baseband PMU, we also have VRF LO 1V5, which is this one here. 1V15, sorry, so we have 1.18, so we're fine with it. This is the main line. I don't know if there's something else. I'm pretty happy with what we've seen here. Okay, so here we have another 1v8 line. Here we should have, yeah, 1H and one 3.3 line, yeah, and it's that 3.3 top. All right. We should have the speaker amp V boost here, but I don't have any issues with the speaker amp. Yeah, and it's there, 2.6 volts. All right, and we can also see the XCVR. It has 2 lines here, but I think they are shared with the baseband CPU. So this is VRF LO1V15, the one that we just measured, right? So it's there. And we should have another line here, the DIG 0V9. 0V9, and it's present. We also have the 3V15, but that comes from the top, so we won't have it here. So from the baseband PMU perspective, I'm very happy with it. Well, I'm sad it's not a baseband PMU because it would have been simpler. I think the only sensible thing to do is to do a swap. I have a board here prepared, so we're gonna go through the swap together. We're gonna move the Wi-Fi IC, the baseband CPU, and then we're gonna copy over the baseband EEPROM data. This is extremely tiny, the baseband EEPROM, it's right here. I don't really want to risk removing it, especially that this one is underfilled, so we're gonna use the JC tool to copy over the data, and hopefully it will work. I'm a bit reluctant because I'm not very happy with the 11 Pros when they get dropped. I've seen a lot of cases where the baseband CPU is actually dead, and I couldn't recover and make them functional again. So let's remove this one and proceed with the swap. Alright, so I'm gonna come with 240 degrees and 30 air. And we're gonna soften the glue here. Let's do like that. Okay, perfect. I don't care about the surrounding parts. I just need to remove this one fast because I don't want to heat it up too much. As I said, on these 11 Pros, I find this extremely sensitive. So I'm just gonna abuse this. Even if I shift all the parts around, I don't care about them. The only thing we care is the baseband EEPROM there that we need to copy the data from. This is clean. Let's move to the Wi-Fi chip. This is a hefty big chip. Okay, so I was a bit aggressive because I didn't want to put much of heat stress on these chips, but I think we're done. I'm gonna go to like 365. 365 and like 60R, and let's try to remove these chips. Not forcing them, this is a very large one, it's taking a lot of heat. Alright, the phase off, looks good, nothing broken. I'm gonna put it aside and let's go for the baseband CPU. Sorry, you can't see it very well. Alright, so the CPU is off. There are a few broken pads from the board, but those are NCs, so we don't care about the board anyway. Alright. And now the only thing left to do is to copy the EEPROM data. So for the EEPROM we have an 1V8 line here, then we have the clock line, that is quite difficult to access. Okay, and the data line, okay, so they are close to each other. Let's see if we can stick the wires here. Let me clean this goo first. Right. Oh, you didn't see, sorry. So I've cleaned the underfilter just for a bit. I'm gonna use some IPA. Alright, so that's all we are interested in. And now let me get the programmer. Okay, let me show you what I'm using. So I'm using the V1SC. And I have here some lines for clock data and 1V8. Right, so let's go ahead and connect this to the board. Yeah. Okay, I'm gonna have to replace the tip on the soldering iron. I need a smaller one, like that. I don't understand what's wrong with this tip. Okay, and let's have a look here. So, let's look on the schematic. We have the clock line here, 1, 2, 3. The fourth one is the clock, and the data is one down. So fourth one is clock, data is one down. Alright, I'm gonna need some flux. Right, so we start with the clock line. And let's see. we need it here on the 4th. Okay, I think we're good. Clock, and then we have data, which will be the one down next to it, which will be this one here. Okay, that's not properly soldered. Okay, oh man, made a mess here. Let me connect back the data. Alright, now we need the 1v8, which is this cap over here. Alright, so this cap we're gonna have 1v8 and ground. We're gonna use it for both. Let me grab my wires. Alright, so 1v8 is near the EEPROM and okay, and the ground, I'm gonna use the same cap for the ground. Okay, so ground is there, we have all the wires. Let's get a bigger picture if we can. Right, good. And now I'm gonna power on the programmer. You can't see it because it's facing the other way, but it's not important what's on the screen. It's powering up. Okay, we go to EEPROM. Okay, and it sees the EEPROM. I'm gonna connect it to the computer. Let me switch on here, and then we go to chip repair. It's detecting the device, it's detecting the baseband chip. I'm gonna read it. Okay, so it's read correctly. I'm gonna save it. I'm gonna name it okay, so we are good with this one. I'm gonna disconnect the programmer. We don't need this anymore for now. I'm gonna turn off the programmer, and I'm gonna desolder these wires. They have done their job, and now, okay, you didn't see anything, that's good. Alright, so now this board I'm not gonna need anymore. I've copied over the EEPROM data. Now I get the one, this is a clean board. Sorry, there's not much light here. It has its own EEPROM data, so now I'm gonna copy over the EEPROM data to this board, but for this I'm not gonna connect the wires. Let me switch it back like that. I'm not gonna connect the wires as I did now here because I don't wanna mess up the pads. I'm gonna connect them on the other side, because if we look on the schematic, right, for example the clock line, we can see it has a point here on the other end. So I've already cleaned those points. This is the 1v8 line. Alright, let's look where it is. So 1v8 is this one here. Let me connect it. Okay, so 1v8 is connected. Now let's see the other ones. The clock. Where is the clock? So the clock is right, this one here, and the data is here. Okay, let's go a little bit closer like that. Okay, so clock. Let me get the clock. This is the clock wire. Clock, okay, and the data is the other one here. Okay, and we need a ground, and I think these are grounds. I have a very small tip. I hope we can solder something with it here, even if it's not sticking well, but I just need a tiny bit of connection. Okay, that's enough. Alright, so we have now all the wires connected. I'm gonna power on the programmer again. Can you see something? No, you can't. But again, no worries. Once it powers on, it should detect, I'm going to the EEPROM option. Yeah, and it should detect the model, and it detects it. Let me connect it again to the computer. Alright, so let's go to the computer. Yeah, so now if I read, you see it read the one that it's on this donor board. I don't care about it. I'm gonna open the one that we have saved, and I'm gonna write it. Yes. Alright. It's reading it. I can do a check. Correct. And that's it. We are safe. I can disconnect the programmer. I will turn it off, and I'm gonna remove these wires. Yeah, so wires remove. Let's clean a bit the board from the flux. Okay, so the board is like new. Alright, let me put the programmer back in its case. And next thing is to actually clean and reball the baseband and the Wi-Fi IC, but it's quite late today, so I'm gonna continue tomorrow, and yeah, you're not gonna feel anything. I'm just gonna pause here and resume tomorrow. Bye. Alright, so let's start preparing the Wi-Fi and the baseband ICs for reballing. We need to clean them first. Let's take you under the microscope like that. Okay. So I'm gonna reduce the temp on the solder iron to 280 so we don't damage the ICs. Gonna add a bit of flux. Alright, and I'm gonna use some 148 solder here just to combine it with the high temp solder that is already on the pads. This IT is very hefty, so it's taking a lot of heat, but no worries. Alright, now we can wick it. When you're going such a low temp on the iron, you can feel actually where the grounds are, because it's not melting very easy. I think I'm gonna give it more temp here. I'm gonna go to 320. This is still not cleaning well, so I'm gonna do another round of 148 solder. Alright, so 148 there. Let's try to wick now. Way better. We don't need it to be extremely perfect. Need to cut the wire. Okay, so I think we're good with this one. Right, we can give it a rub in alcohol. I have here a dirty cloth, but it's okay. I'm just gonna rub this one so it gets clean. Good. One down, one to go. Next is the baseband CPU. Alright, this still has a lot of underfill. I'm going back down to 180 degrees on the solder iron. And again I'm gonna come with 148. I put way too much solder on the iron. Okay, so we have a huge amount of pads that are oxidized, as you can see here. I don't really like that. Let me try to wick it, just to scratch the remaining part of the of the underfill. Alright, and now I'm gonna clean it a bit with a cloth with IPA. So that's fairly clean. Now there's way too many oxidized pads here. I'm afraid we're gonna have trouble reballing this one. I'm gonna use here a steel brush just to gently scratch in these pads. I'm not applying pressure. I'm gonna do it in both directions. Alright. And now I'm gonna clean again the baseband CPU. Okay, we're gonna put this aside, and let me clean this holder just a tiny bit. Alright, and now we can proceed reballing this one. Let's see. Yeah, that's good. Let's prepare some solder paste. I have some left over here. Hope it's not too dry. It is kind of a dry. Let's see if it works. If it doesn't, I'm gonna use a fresh box. Just using this soft tissue. Alright. Let's grab the stencil. This is a magnetic base, so I can afford going back and forward with the scraper tool. If you don't have a magnetic one, if you go back and forward, there's chances for a solder paste to get below the stencil. So now I'm using 330 degrees and 30 air just to reball this one. I'm using a 183 paste. Okay, let me clean the stencil while it's warm, because unfortunately I have the baseband stencil right next to it, and unfortunately I did some solder balls on it. And I need it to be very clean for reballing the baseband CPU. chip. I'm gonna add some flux on it. Alright, and let's reflow it again with 330. Okay, so it's reflowed. And now I'm gonna proceed to soldering it to the new board directly, if we still have it here prepared. I just need a few some hot air just to warm up here the board, so I can add a tiny bit of flux. That's way too much. Just gonna spread it around. Alright, so I think we're fine. We'll take our Wi-Fi chip and place it here. Alright, I think it's good. And now I'm gonna come with 350. I'm gonna put 50 air, just because this is a hefty chip. Use kind of too much flux. Let's see if so we can bump the chip. So we're fine. Now let's proceed with the baseband CPU. We have the baseband CPU over here. Have a speck of dirt here. Let me remove it. Alright. And let's put the stencil over. Okay, here I'm gonna use the small scraper tool. It allows me for a more precise action, as these pads are quite small compared to the Wi-Fi chip ones. Okay, so I think we're good. And again, I'm gonna come with 330 and 30 air, and let's see if we can reball this one, because it was heavily oxidated. I'm seeing a lot of flux coming out, so my paste wasn't that dry. Alright, so balls are forming. Good. I think we're fine. You don't see any of them being stuck to the stencil. Yeah, perfect. Okay, let me clean the stencil while it's warm. Got stencil cleaned. Now I'm gonna apply a bit of flux, and again I'm gonna reflow this one with 330 30R. Good, so we have very nice shiny balls, it looks good. You don't really see the 3D version there, but that's okay. So now we're gonna come with 350 degrees and 40R to solder this back on, but again I'm gonna use a bit of heat just to be able to apply a tiny amount of flux. Alright, I don't know exactly where pin 1 is. Let me look on the schematic. So I have 11 Pro RF board and pin 1 where's pin 1? This is annoying. Okay, so it's in this corner right here. So we take this and have it like that. I'm just gonna try to align this the best I can. Alright, so I think this is good. So 350 40R. Okay, so I see it went down in place. I can bump it, so it's fine. Alright, let's clean this from the table and now proceed to reballing the board. To reball the board I'm gonna need it to be cold, so I'm gonna leave it aside for now, and I'm gonna wick this one off, because we need, if we reball it, we need this one to be wicked, the top board. Let me trim the wire. Let's go again. Don't like the way it went here, so I'm gonna do it again. Okay, perfect. Do you see something? I'm using a smaller Barlow lens, so you don't get a very big view, but it's better for me than the high one. So this is a 0.7, and I think I was using a 0.43 in the past. That made my scope very high, my microscope very high, but I didn't have that much granularity in focusing it. So for micro soldering, for me this 0.71 is better. You know, it's quite close to the board. Okay, so I think we're cool. This is good. Now we proceed in cleaning this one. So to clean it, we get our alcohol. Oh Jesus, it's very dirty. Let me clean it. Cool. So let's put some fresh IPA. Freshy. I'm using this type of IPA. Very good. I tried different ones, but I'm finding this one to be the best. Now we clean the board with this heavy brush, just the interposer connection, and now I'm gonna take a soft brush. This is a very soft one, and I'm gonna rub the entire board. Just like that. Alright, let's get a clean cloth. And we dry this out. It's yeah, I think it's looking good. Alright. So now that the bottom board is cold, we can proceed in reballing it. Let me get the stencils. I'm gonna use this one. From here I need this thing to cover the seam tray. Well, the seam holder, or however it's called. I'm not gonna use this part here, so you can put this over the stencil and just go around until it melts. I don't like it because the stencil still deforms. So I'm just gonna put the solder and then leave the stencil. Alright, so we're done here. Let's get some paste. We have the 148 mechanic one that apparently bottle is almost empty. I think I did too much, but that's it. And it's a bit too wet, so I'm just gonna dry it out, and that's it, not too much. Alright, so let's go under the microscope. I think I'm gonna get this small tool here, and let's try to fill in these holes. I'm gonna start with the hardest part, which is this part here around the SIM tray. Good. It's not very wet. I think I would have preferred it a bit more wet than it is, but I think it's gonna do. Alright, I think we're good. Now I can remove this thing, and I'm gonna lift off this one, and let's see the result. And I think it is great. We have covered every single one of them, so it's not bad. Now first thing, I'm gonna clean my stencil. I have a separate thing for the stencil. So first I'm gonna use a cloth just to remove the paste of it. Yeah, and then I'm gonna give it a bath here. In this case, so this is different, not the one that I use for board cleaning. This is something I use only for stencil. It's still only IPA here. I'm just gonna brush it good. Alright, so we're fine here. And now I can just wipe it with this cloth. So these cloths, again, I'm keeping them in the drawer with this one because fine balls are stuck in here in these ones, and you don't want to clean something else besides these stencils with them. Alright, let me put the tools back. I'm gonna remove the board from this holder. Okay, so now we can get back to this job. I'm gonna put the excess paste in this tube because I'm gonna reuse it for soldering and cleaning. Clean this. I'm sorry, but I'm a bit pedantic with my tools, so I tend to take care of them during the repairs, not after. Okay, and let's put something here under this board like that, and we're gonna use 350 degrees 40 air to reball this one. Let me switch it to the microscope. Alright, and let's gently start from this part here. Alright, so we have nice balls. While it's hot, I'm gonna apply some flux so we can proceed in soldering back the boards together. Okay, it's perfect. Let's put it on the heater and try to align the boards as best as we can. This is a bit bent. Alright, let's see how it looks. Don't think you get a good view here, but I do, and that's the important part. So we're cool. I'm just gonna start the heater, and I'm gonna come back to you when it's done. I'm gonna pause the video now because it's gonna take about 3 minutes. Alright, so I think we're almost there. Just to make an idea, this eye repair is set to 190 degrees and 240 seconds. I'm about at 60 seconds now, but when it's about 20 off, so when it's set to 190 it hits up to 170, which is what I want this case. So I'm just gonna bump the board, yeah, and I can see it moving. I think you can see that too. Yeah, so I'm gonna turn it off. Alright, and I'm gonna let it cool off until it reaches about 90 degrees, so we're at 170 now. I'm gonna pause the video again and come back when... Right, so the board is cold now. It's really cold because I stopped a few hours ago. Looks reasonably good. Let's clean the flux a bit. Alright. Let's put it here in the phone. I need a microscope at my age. Da, liniștită. I didn't even test it on the power supply. Hope there's no shorts. Right, let's see. Does it power on? So I have Apple logo. The problem is that I've already deployed an update, so we're gonna have to update it again and see if the baseband will respond. Okay, flashlight works from the start. That's a good sign. Let's look under settings. We have Wi-Fi. Okay, so Wi-Fi works. In general informations, we have no modem firmware there, but again I'm gonna have to update it. So let's connect it to the computer. Alright. And let's see. We're gonna retain the user data, click flash, and now just I clicked abort, damn it. So flash, finish, yes, switch view and see how's it going. So we're now sending the baseband data. Now it's important to see if it goes further or not. If not, unfortunately I think we're gonna have a problem with the baseband CPU. Hey, and it worked, so it saw the baseband because it now moved to rows. If it wouldn't have seen the baseband, it would see error, device baseband didn't respond or something like that. But we're fine, we're passed over that. Yeah, I'm gonna pause the video here and resume once the update is complete, because it's gonna take a long time. Okay, so flash has finished. We get a no SIM available, and that's very good news, because it seems we have baseband now. Let's make a test. And we have IMEI, so that is good. Apparently we had a defective bottom board. It was on the baseband PMU, but in this video I think you could see advanced diagnostics and how to investigate if you really need a swap, or you can still repair it. Thank you for watching, and see you soon. Bye.